I thought it might be useful to make a video that goes through some of the common numbers that we use in talking about coronavirus, and I wanted to do this specifically in the context of Connecticut school reopening. Every day, the state puts out new numbers of how many new cases we've had in Connecticut and how many total cases, how many deaths, how many hospitalizations, and a whole bunch of other information. First, focus on the daily new case count. This means that there were 75 people diagnosed as having COVID on this particular date. So the 75 has units of people, and it's a count. This number is the total. It's the total number of coronavirus cases that we've had in Connecticut over all the time that data has been collected, 50,000. And this is also a count. It comes in number of people. And the problem with data given as counts is it can become hard to compare. So how does 50,000 cases in Connecticut, where we have about 3.5 million people, stack up against Florida that has 500,000 cases, but then they also have 21 million people? So counts can be hard to compare. By the way, I should say before we go on, there's a little more subtlety to this because sometimes when you look at the numbers, they're broken down into confirmed and suspected counts. Usually the suspected counts are so small that it doesn't matter whether we include them or not, but it might sometimes account for the difference between someone who got 508 as a total and someone who got 516 as a total. So there is a subtle difference between confirmed and confirmed plus suspected cases. Anyway, for comparison, we usually talk instead about rates. We could take Connecticut's count yesterday, 75, and divide it by the population of Connecticut. We could take the total number of cases we've had so far and divide it by the population and get these numbers. And they're hard to use because they are long decimal numbers. It's hard to remember how many zeros were in there. And the awkward part about these is the number that they're giving you, the units it's measured in, would be cases per capita. And that just winds up being a funny concept that's hard to communicate and sort of hard to think about. So we don't generally use cases per capita. Instead, we take that cases per capita and multiply it by 100,000 to get a number of cases per 100,000 people. This has the benefit of being like numbers of a size that we're familiar with, that we are used to using. And also it makes sense. I mean, 100,000 people, well, the city of New Haven has about 130,000 people in it, so you could almost say probably yesterday New Haven had about 2 new cases. Probably for all time, New Haven has had about 1,437 cases. So these feel like more meaningful numbers, and they are the rates that we usually use to compare how, say, Connecticut is doing to other states and other countries. Another term you'll see for this is the incidence rate. This is what allows apples to apples comparison. So if Connecticut has had 1,437 cases for all time per 100,000 people, and Florida has had 2,412, you can see that Florida has been hit almost twice as hard historically over all of the course of the epidemic by the coronavirus. Now I should give you a little warning. Several governors, are very interested in the test positivity rate. And the test positivity rate is not the same thing as the incidence rate. This is the number, or the percent, is usually given as a percent, of tests that came back positive. The problem with that is it depends on how many cases you have and how many tests you've given. So you could get a 1% test positivity rate in a number of different scenarios here. What we use test positivity for is to say whether a state or a country is doing enough testing. And the World Health Organization, the CDC, they want to see the rate below 5%. If you have a test positivity rate below 5%, chances are that your case counts are fairly real. You're getting a pretty real estimate of how many cases are in the state. But it's not the rate of the population infected. It's very dependent on how many tests you do. So it shouldn't be used as a descriptor of how bad the epidemic is. It's a descriptor of, are you doing enough tests? And Connecticut is. Connecticut's doing great in giving tests. So we don't really care. I mean, and some people care for some reasons about how the entire history of the epidemic has affected the state. But most of us are interested in what's going on right now. What does it look like out there in the state? And so we like to look at the new cases that we've had lately. The problem is the new cases are what they call noisy data. There's a lot of variability in the cases that are reported. First of all, the state has decided, and this is fair, they've decided to take Saturday and Sunday off. So they don't report any cases on the weekend, and then on Monday we always have a large number that represents the cases from Saturday, Sunday, Monday. But other things affect the reporting rate. For example, we had a hurricane in Connecticut on this Tuesday. Now, that probably didn't affect this Tuesday number, although maybe the state itself had some electricity problems. But it takes a few days for the tests to go through the system. So it very well may be that that low number on Thursday was because not too many people went out for coronavirus testing in the hurricane, only the people who were sick enough, for example. And a frequent thing you'll see is a low number followed by a high number as they sort of revert to the mean. So it could be dangerous to make important decisions based on one day's worth of data. You might, I mean, if you looked at the data on Monday or you looked at the data on Thursday, you'd make a very different decision about what the condition of the disease in the state is right now. So to handle this variation, we tend to smooth it by taking a weekly average or a 14-day average. First thing we do is add up the cases to get the weekly total. So even though there's a lot of variation in the daily total, 508 cases for the full week, and then divide by 7 to get a 7-day average. So each day, the average, what you might expect to see on a day, is about 72.5 cases. Notice that on no day did we actually get 72.5 cases, but it's an average for the week, and it sort of is representative of the level of the virus that week in the state. Total count, not per capita. We can make it per capita, again by dividing by the population, multiplying by 100,000. And this number, the 7-day average rate per 100,000, we took the weekly average, divided by the population, multiplied by 100,000, and got 2. And 2 is a nice, easy to communicate number that represents an apples-to-apples comparison with other locations or other times at which someone did this calculation. And this 7-day average rate per 100,000 is the rate that the state is using to make decisions about school reopening. I think you may have seen this. This is the governor's slide on this is the metric that we would be using to make decisions about when it's safe to have school in person, whenever that metric is less than 10. Oh, look, if you look at the little footnote here, 7-day average per 100,000 population, we just did that. So whenever that's below 10, and ours is 2, this metric says it's okay to have in-person learning. Between 10 and 25, this metric says hybrid is probably better. And if we go over 25, it's time to do remote learning. There are some problems with these cutoffs, and I want to talk about those problems. But first, I just want you to understand what the numbers are and what they're saying. we can take that 10 cutoff and 25 cutoff and work backwards. We can unpack the multiply by 100,000 by dividing by 100,000. We could unpack the dividing by the population by multiplying by the population. We can work backwards to find out how many new cases per day on average correspond to those cutoffs. So doing the math, we get that the cutoff of 10 in Connecticut corresponds to about 350 new cases per day. And the 25 cutoff, which is the range is 10 to 25, is for about 875 new cases per day, again on average. These numbers are interesting and meaningful. Here we have a graph. The purple curve is the history of the epidemic in Connecticut. If you look, the purple curve is smooth. It's actually a 7-day average curve. And these crazy jumping points here are that day-to-day data variability that I was talking about. So this purple curve is the smoothed course of the epidemic in Connecticut. We are right here at the end. I've put in 2 lines. A line for that corresponds to 350 cases, that 10-day cutoff, and a line for 875 cases, that 25 cutoff. And so what the governor's plan anticipates is that we would be in person until this level, and that students would still be going to school on a hybrid model all the way up to almost the very peak of the epidemic in Connecticut. The only time the governor's plan anticipates schools going remote is when we are all the way back to the worst condition that we had in, say, April. That's a little shocking. So I did a little bit of math, a little bit of research, and I included some of the computer code because now you have the machinery to understand some of this. Total rate per 100,000, here's the 100,000 times the case count divided by the population. Here's where we make it an average by dividing it by 7. And we have a column here, average rate per 100,000. Oops, sorry. This column shows all of the states with the metric that Connecticut has chosen to make its decision on. And I've sorted them in descending order so that you can see that there are a lot of states in the country that do have that metric above 25. It's kind of shocking, actually. Connecticut is in the bottom handful. Again, in the U.S., among the U.S. states. But I also looked at other countries. I managed to compile a list of 38 countries that had reopened their schools. This isn't quite a complete list in that I only chose countries that had a national reopening date. So some places like China and maybe Canada. No, Canada's going to open in the fall. A few large countries made local decisions state by state and are not included here. These are ones that generally had a national opening date. But it's most of the countries that have reopened their schools. And I did the very same math. These numbers, every number in this table is from a different date. It's calculated as of the date the country reopened its schools and the case count 14 days prior, again converted to a daily average per capita times 100,000. So these numbers are exactly comparable with the state of Connecticut's numbers and with the numbers in the previous slide for the states. And you will see that there is no country in the world that reopened their schools with an index of above 10. And most of these on the list, including some that are below 1, opened their schools with a gradual phase-in to a hybrid model. Some of them only allowed the kindergartners to come back. Some of them only allowed the high school seniors to come back. There are a few on this list that were full reopenings, but no country in the world opened their schools with an index of greater than 10 on their reopening date. Just to see the same information graphically, we often see Connecticut compared to South Korea and Japan. Here again is Connecticut's epidemic curve. It's been rescaled to cases per million. And you can see the comparable curves for South Korea and Japan. They are these yellow and purple lines way at the bottom, almost so low that they don't show up above 0 on Connecticut's scale. So this is where they were when they phased in their school reopening. And again, this is Connecticut right now. I should mention while we're looking at this that these two high points were data dumps. They were historical data that had been collected out of state. And so they pull up the curve a little. The real curve is probably, more like this level right here. But it's still an order of magnitude higher than Japan and South Korea. But Japan and South Korea are exceptional. Japan is an island. They're high-tech Asian nations. So let's look at some European nations. Here's Connecticut's curve again, compared to Denmark, Germany, and Italy. Italy hasn't opened their schools yet. Denmark was fairly close to Connecticut's rate when it reopened. And they have, their rates have gone down since they opened. But again, they are well below Connecticut's rate. Here are some less wealthy countries, Vietnam, Uruguay, and Thailand. I suppose perhaps I shouldn't have included this slide because you may say some of these countries don't have adequate testing. I don't know. I haven't looked it up. But again, near 0 rates. Here are Connecticut's nearest peers in the country reopening list. These 4 countries had about, in indices of about 2, maybe Belgium and Portugal were a little higher than 2. So these are Connecticut's nearest peers on their date of reopening. And, you can do the research yourself and look at how school reopening played out in Israel and South Africa. I'm not claiming that the burst of cases in Israel and South Africa is due to their school reopening alone. I don't think we can possibly know. But it's not guaranteed that your case rate will stay low after you open your schools, is really just the point of this slide. Thank you for listening.